This is a video talking about the tool that I'm going to be using in our class to do some visualizations. I've already shown you one called matplotlib. This is one called visvis, and you can find it on Google Code. The link is up here, or you can Google it. They explain pretty well why we might want to use it, and provide a link to download it on Windows. I believe you can install it on whatever operating system you want to using pip. So here we see Spider, which is the development environment I use in class, and we have a regular Python shell here. You can't do interactive stuff inside of the IPython shell in this version of Spider. See, there's the little warning here. So if you're using Spider, make sure you don't have this GUI interactions warning. In the regular Python shell, we can plot data using visvis. If we start off by importing it, so I'm going to import viz as VV to give it a short name. No errors, so we're good. So let's create some data. I'm going to import numpy as NP, and numpy has the numerical algorithms that we use for scientific computing. One of the more important ones is one that allows us to create grids of data, or arrays of evenly spaced values. The way that it works is I can say np.mgrid, which creates a mesh grid, and then I use the square bracket, and I use slicing to indicate what values I want. So I can generate numbers between 1 and 10 by pressing 1:10, and the way that it works is it'll start at the first number and it'll end just before the last number. So I have 1 all the way up to 9, so it doesn't include 10, and by default it's spaced evenly. I can also say go from 1 to 10 by 2, so kind of read that as start from 1 up to, but not including 10, in increments of 2, and that's what this slicing notation means with the 3 colons. And if I hit enter, I see it's 1, and 1 plus 2 is 3, 3 plus 2 is 5, 7, 9, and it doesn't get 10. So in Python, you can represent real variables. So if I say x equals 3, and I go to the variable explorer, I can see that x, the type of x, is an int. I can set x equal to 3.0, and x is a float. But I could also set x equal to 3j, and if I hit enter, and wait a second. Let's just not exclude that. It was not showing me complex things, so I need to look for x. So x here is 3j, and the data type here is complex. So you can represent complex numbers in Python by using a j, which is useful in general. But in NumPy, if I use mgrid, and I say I want to go from 1 to 10, but I give it, instead of a I want to go by increments of 1, for instance, what I could say is I want to go from 1 to 10, and I want to generate 100 values in between there. So I would pass in 100j. So the difference here is instead of telling it what the step size should be, I tell it the total number of items that should be produced. In this case, it produces the 1, it produces the start value, and it also produces the last value, and the total number of what's produced is 100. So this is a different way, a more useful way of generating linearly spaced data. In other packages, that would be called linspace, right? So we're going to use this to generate some data. So if you imagine there's a function, it has a domain and a range. So I'm going to say we've got some function f of t, and t is going to equal np dot linspace, not linspace, mgrid. Sorry, I just said that it's called mgrid in numpy. And I'm going to go from negative 3 or negative 4 to 4 in increment, and I'm going to generate 100 values. So now T is that big long array of data, and I'm going to set f equal to, and then in numpy we've got these functions like abs and cosine and sine, which take the cosine of the entire array. So I'm going to set f equal to the cosine of t. Alright, and if I look in the variable explorer for f, which is way up here somewhere. Let me see the E, F. So f is this array of 100 values, and I should be able to plot them with visvis. So if I just say vv.plot, so plot takes x, and then you can plot y as a function of x. So t f. So first the kind of the horizontal axis and then the vertical axis. This should produce a 2D plot, and there we go. We have a 2D plot in visvis, and we should be able to add some stuff like x label t. It added the label t to the x-axis, and vv.y label f to add y f to the label of the y-axis, and you know, your typical things. VV, I think we can give it a title, cosine, and there's the title of the plot. So we can do the things that we want to configure it. VV.axis. We can, if we want to get, if we want to plot the axes with a grid, I should be able to say vv.get the current axes, and then I should be able to specify let me say axes equals vv.gca, and then axes dot axis. So axis is I consider a difficult name to remember. Axis is really a subplot, and then axis is the information on the actual you know, this business, the numbers and the ticks and all of that. So axis dot axis dot, and then we have some other properties we can modify which are useful. One is show grid, and I can set that to true to configure it, and now we can see this nice grid over it. And you know, while you're in there, you probably noticed some other properties. It's not a bad idea just to thumb through all of these and try to figure out what some of them are. So there's a show minor grid, for instance, and that can be set to true. That's a property. If you're not sure what's what, you can go and look at a Google, so we can see now a much tighter grid. And I think I'm going to stop there on this 10-minute video. You've seen the minimum part of visvis. I'll try to pick up and show a little bit more about laying out a figure.